Hello everyone, welcome to Collegewali PADHAI. So in today's episode, we are going to learn about vector calculus, and this is the ninth episode of mathematics. So let's get started with the video. So without moving here and there, let's start directly with the topic, talking about delta. Here delta is ulta, and delta is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So this is the main formula which will be applied to both scalar as well as vector form. This formula will be applied to both scalar as well as vector form. So if we proceed towards the scalar form, then it will be del f. Del will be this whole part, that is I into dou by dou x plus j into dou by dou y plus k into dou by dou z whole into f, and this can be otherwise written as, or excuse me, I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. This can be also called as gradient of f or grad of f. It would be better to say gradient of f. Now let's revise this thing. So we got delta. Delta is equal to I dou by dou x plus j dou by dou y plus k dou by dou z. This can be written in both scalar as well as vector form. First, if we consider the scalar form, we get dou of f. Dou is this, that is I dou by dou x plus j dou by dou y plus k dou by dou z whole into f, and the gradient of f is I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. So let's recap about dot and cross product. As we have learned in earlier classes, that dot product is dot product. Suppose let a vector is equal to a1i plus a2j plus a3k, and b vector is b1i plus b2j plus b3k. So then how can we find a vector dot b vector? So first, if we consider a vector, this part will be taken over here. B vector, this one will be taken. So if we take a1i plus a2j plus a3k dot b1i plus b2j plus b3k. So this can be written as a1 into b1. So this can be written as a1 b1. And in case of dot product, I dot I is 1 and j dot j is 1, k dot k is 1. So a1 b1 plus a2 b2 plus A3 B3. So this was the dot product, and next we shall talk about cross product. Cross product. Suppose A vector cross B vector. How can we? And cross product is found with the help of determinant. So I, J, K. This is A1, this is A2, this is A3, this is B1, this is B2, this is B3, and we have to take its determinant. Suppose first we take I. If we consider I, then we have to hide this part and we have to consider this part, this into this minus this into this. You must have seen. So I will undo this and do it again. Then this will be A2B3, A2, sorry, A2B3 minus B2A3. And remember, this is plus, this is minus, this is plus, as we had learned earlier about in determinant. Minus J A1, and now we have to hide this one and consider this minus this. Now this can be written as A1B3 minus B1A3. Now we have to come to K plus K. Again we have to hide this part of the K and we have to consider this minus this. So K can be written as A1B2 minus B1A2. So this was about the cross product. So we discussed about scalar, we discussed about dot product, we discussed about cross product. Now we have to move towards the vector part. Now we have to move towards the vector part. So F vector is equal to IF1 plus JF2 plus KF3. So this is the vector part. Now, deriving from the vector part, we must come to the divergent and curl part. Here, from this equation, we can talk about divergent and curl. First, let's talk about the divergent part. Divergent is, this is divergent, delta dot F, and this is divergent, and curl is delta cross F, and divergent can be written as dou F1 by dou X plus dou F2 by dou Y plus dou F3 by dou Z. Whereas curl can be written as here I, J, K, and here dou by dou X, dou by dou Y, dou by dou Z. Here F1, F2, F3 whole determinant. So in vector we got this IF1 plus JF2 plus KF3, and from the vector part it is diverted towards divergent and curl part. Divergent is delta dot F and curl is delta cross F. Delta dot F can be written like this. Delta cross F can be written like this. Then let's move or talk about some formulas. Now we have covered scalar part, vector part, and in scalar part we covered gradient, and in vector part we covered about divergent and curl. Now let's move towards the normal vector, unit vector, and directional divergent vector. So how can you find a normal vector? How can you find a normal vector? Suppose this is n vector. So this is equal to gradient of f. This is equal to gradient of f. And unit normal vector. Unit normal vector that is n cap that can be written as gradient of f divided by gradient of f mod. Then at last we must know about the directional derivative. We must know about the directional derivative in a direction or in a vector direction, that can be written as gradient of f into a cap. So these three formulas are quite important. Normal vector can be found by or is equal to gradient of f. Unit normal vector is gradient of f divided by gradient of f mod, and directional derivative in a vector direction can be found with the help of gradient of f into a cap. So now let's talk about angles. When we talk about angle in vector calculus, so cos theta comes in our mind. But suppose, how can you explain that? If f and g are scalar, if f and g are scalar, and if it is told that find angle at this point A, B, C, How can you find this? Question is f and g are scalar and you need to find the angle at point A, comma B, comma C. So what might be the formula? Cos theta equal to gradient of f into gradient of g divided by gradient of f mod into mod of gradient of g. So this needs to be raised. So this is the formula which needs to be remembered. Yeah. So this is the thing. And how to find angle? Formula is this. Cos theta equal to gradient of f into gradient of g divided by mod of gradient of f into mod of gradient of g. So this was the concept of vector calculus. Thank you for watching the video. Do subscribe to the channel, like the video, share with your friends to learn more. Thank you.